Let's look at what's referred to as average rate of change. And what I want you to notice is that actually what it's telling us here is that it's actually really just finding a slope. So if you notice, I have a few different formats for the formula that can be written there. But we're going to focus our attention on this one. And what I want you to think about and consider is the fact that it really is finding a slope. So let's talk about why that is here in just a second. So let's take a look here at what this is showing. We have some graph here, this f of x function, this curved graph here, right? And if you notice, we have 2 points that are part of that particular graph. And so you're going to be given an interval like that where you're given 2 particular points. And when we're looking for the Aroc, or the average rate of change, think about what that really means. It's the measure of how much the function changes per unit over that interval. Okay? It's really derived from the slope line, because as you notice, we have this red line here that's going across here. So essentially what we are doing is finding the slope of that line, because that is going to give us the average rate of this change, or of this difference. All right, so let's see how we actually use this formula. And this is kind of an extra format for times when we are not given actual values, if we're just plugging into a function. So we may get to some examples of that, but primarily you're going to see examples similar to what you see here, where it says, find the average rate of change of this function, of this particular function, as x changes from x equals 2 to x equals 4. So what that's telling us is that we need to figure out what the corresponding y values are for each of these x values. So if we plug in x equals 2 into that function, so if we find f of 2 into that function, we get 1 minus 2 squared. So we get negative 3. And if we plug in 4 and find f of 4, then we're doing 1 minus 4 squared. We get negative 15. So we have these 2 particular points. We have the points 2, comma, negative 3. And we have the point 4, comma, negative 15. And now to find our average rate of change, I'm going to abbreviate that, Aroc. We are truly just going to find the slope. So we are going to do negative 15 minus negative 3, and I'll clean that up in just a second. And then we'll have 4 minus 2. So this is going to become plus a positive. So we get negative 12 over 2. So our average rate of change is negative 6. In other words, for each unit we change along the x, we are going down 6 units along the y. Let's look at another example. Average rate of change for this particular function. If we plug in and find f of negative 1, then we're doing negative 2 times negative 1 plus 7, so we get 9. And then if we plug in 3, we're getting negative 2 times 3 plus 7, we get 1. So think about what your points are. For me personally, I'm so used to writing that slope formula, so I really like to write this as given points, so that then I can very quickly and easily find my slope. So we're going to call it Aroc instead. So we're doing, in this case, I'm going to do 9 minus 1, then I'm going to do negative 1 minus 3. So we get 8 over negative 4, so we get an average rate of change of negative 2. just realized I should probably show you an example where you can see this visually on a graph also. It might help you see what exactly we're doing. So I'll try to come up with an example and share that in class with you. All right, this is a pretty small interval. We're just going from 3 to 4. So if we plug in 3, we're doing 2 minus 3 squared, so we get -7. And if we plug in 4, we get 2 minus 4 squared, so 2 minus 16, so -14. And if you want to write these points, so 3, -7, and 4, -14. So our Aroc, our average rate of change, is going to be -7 minus -14 all over 3 minus 4. So we get, what do we get here? 7 over -1. So our Aroc is equal to -7. So think about the fact that these are slopes, right? And so you can imagine from point to point, if we were to graph these, the fact that this means this is going from top left towards bottom right. Actually, all of these Arocs, all of these slopes are negative, so they would be going from higher to the up and higher to the left to lower down to the right on all of these graphs. All right. I hope this helps just in terms of plugging into that formula.